Okay, good. Yes, so I am not going to show slides. I'm going to talk and read a little. But I thought I should put up this one I was offered. Don't you want to put up anything? So I said, yes, let's put up this one. This is, does everybody know what this is? Okay, this is the famous 2010 article in Nature, which created so much turmoil, or as some people call it, a dust up. I think it was more than a dust up. Okay, my accent, you are going to wonder about it all the time. Yes, I'm from Finland. So I have some kind of mid-Atlantic version of English.
I think you will speak a little louder.
Louder! Okay, will do. Okay, so.
I'll do it again.
It has to be high up because this is the stupid part. Where do we put that here? Okay. Is it better here? No, not at all. Put it on the collar here. Not, no.
And just speak up.
Okay, speak up. Okay, good. Yes, so because I studied the sociobiology controversy, things continue. I mean, and now it has popped up again in a new form. So I feel that I should look at it, and actually I want to look at it too. How did I come about writing about Hamilton? Actually, I was asked by Oxford University Press to do that, and I felt rather honored. And it was a rather big challenge because he was a very complex person. And but because he was so creative and because he was so complex, and because I am a sociologist of science, actually, I took it as a challenge to figure out how a particular individual in science, who is very creative in the first place, comes about his ideas. And then how he convinces himself that actually there is something to it and he is not a crank, which actually could be the case when you have really creative ideas. So he had a long struggle with himself before he published something. And then how he continues struggling with the scientific community, because you have to convince your peers. So it turned out to be a rather interesting journey, and I actually traveled around, and I even went to New Zealand to speak to his relatives. It sounds very kin selectionist, this one. But he actually never visited New Zealand until he was giving a Roosevelt lecture in the 1990s. So I don't think he was so much influenced by those. Anyway, I have no particular affiliation with kin selection. I have just done a book on Hamilton, but I am basically very open to actually what's going on. I'm a sociologist, remember, so my heart warms anytime I hear the word norm, and lots of people here, Rob and John Silk and so on, and their colleagues are investigating cooperation. Thank you. Are investigating cooperation now in humans and using various kinds of empirical methods, and it is just so fascinating. I have been talking to them, to these people, and I will continue for one more day, and it has been absolutely wonderful. Okay, but now I'm supposed to give this lecture. I think I will read pieces from a paper that I have written so that I don't make any mistakes. We have a limited time, but I will then discuss general themes. So, so the field of evolutionary biology has recently become an exciting area of inquiry again. And we have this militant attack on kin selection by Harvard's E.O. Wilson and Corina Tarnita and Martin Novak. And in the journal Nature, which is a kind of it represents symbolically a very big statement, and also it means that it's backed up by the scientific establishment in some way. Well, one can discuss actually what it means to publish in Nature, but it created the kind of effect I think it was intended to create. And I think my bottom line is that this has been a healthy kick in the pants for the kin selection researchers, They have been invited, so to say, to look at their own field, examine its theoretical foundations and also its empirical basis. And I must say that my conclusion is, looking at that it has come out looking very good. And I think seldom has a field been so much examined for mistakes or inconsistencies by its own proponents. At the same time, a lot of semantics has been analyzed, and it has turned out that there are many, many misunderstandings or dual use of terms and so on. And I think my first impulse, because I'm a kind of peaceful analyst in some respect, my first impulse was to see, are there some basic misunderstandings that go back all the way to the sociobiology controversy? Is it so that some people got stuck with some vision of what things were and they never revised them, and now when this new controversy starts, the old perceptions are there and they have not been re-examined. So, for instance, okay, let me start. So, who here is here don't know about sociobiology and don't know about the sociobiology controversy or something? Everybody is very much with it. We have a few people. Okay, good. We will accommodate you because I don't know to what group I'm talking here. So anyway, backtracking now. In sometimes between 1960 and 70, in the 70s, it seems that a paradigm shift of sorts. I don't want to go into detail what a paradigm shift is, but a big shift happened in biology. There was a rather radical move away from something called group selection to something that was getting the name kin selection. And I say a radical change because I've heard people tell me that if you, that in the 60s, you had to be a group selectionist because that is what everybody was. But in the 70s, you better be a kin selectionist because otherwise you wouldn't get hired. So there is a kind of movement inside science towards particular ideas. And there is also a kind of phenomena like this. So also another aspect of this is that at the individual level, I spoke to some people when I did my old research, and they told me that they had gone through a kind of personal conversion, which was similar to a religious conversion. They had, so to say, seen the light. They had seen a different way of looking at evolutionary biology, about evolution. And that was a switch from this kind of general talk about good for the group and the interest of the group and adaptation at the group level and so on, which was taken as for granted in some way. And some models were developed, but there was not really a solid unified model for that. So for many people who had not been very happy with the availability of models because people want to do research, and at this point I think the pressure for quantitative proof was getting much stronger. Many people were very happy when Hamilton came about. Hamilton came up with his idea of inclusive fitness, and then the so-called Hamilton's rule, which is such a simple formula, which says the following, to those who don't know, that Hamilton's point was that he can show that it is not at all so that altruism is something that just exists, let's say, in human society and and with motivations and so on. But altruism actually is something that is a ubiquitous phenomenon in nature. I mean, that sounds counterintuitive because altruism, when you die, you know, when an individual dies at the extreme of altruistic sacrifice, the individual doesn't exist any longer. And Hamilton's great contribution was to say we shouldn't look at the individual, we should look at the genes in the individual. And where are the genes? They are in the individual, but they are also in all kinds of other individuals, mostly probably relatives because there's higher probability, but also in other, potentially in other members of the population. And if they can only get together in some way and cluster and identify each other, they may actually also be able to propagate this altruistic gene. I mean, all this is almost metaphorical speaking because we have not identified such a gene yet. And this was the idea. So that was Hamilton's great contribution, and he had this rule, simple rule that he introduced, which looks simple, but actually into these terms is packed a lot of meaning, and actually the meaning is changing over time also. But it says that the formula is RB should be bigger than C. That sounds rather simple, doesn't it? And what it says is the following, that the benefit given to somebody who is receiving help from multiplied by the relatedness to the helper should be bigger. That if the benefit is bigger than the cost for the helper, altruism can develop. Okay. So it is a very interesting formula, and the R, it's like RB over is bigger than C, and the R is seen as a kind of relationship term or relatedness term. Okay, and everybody was kind of focusing on that R and said, "Oh, R, how are individuals related?" and started calculating relatedness. But many people early on forgot what this B and C was. They were like just terms, benefit and cost. What are they? And only later on was it realized that Hamilton actually had meant it from the beginning, but I don't think he was too explicit about that. That the B and the C actually are all kinds of factors that affect the situation, particularly ecological factors. Hamilton was not at all, by the way, for those who don't know about him, Hamilton was not at all an abstract mathematician or anything. He was not really a mathematician, but he was capable of doing mathematics. And he, hoofing and puffing, was doing this mathematics in order to clarify his own ideas to himself and to others. He was basically a naturalist who actually enjoyed, he almost merged with nature. I mean, he was so close to nature. And that is actually his real mode of being. But then, because he was in a time of neo-Darwinian equations and that kind of population genetic proof, that was, he learned that by himself as he was a student. Nobody taught him that. And he realized that this is the way to go. And that is also the way E.O. Wilson, for instance, realized this is the way to do things, and so on. So it was an interesting transition time in the 1960s between more general naturalistic observation and theory building, and then an attempt to quantify things and making the field more serious. Okay. So what was it that Hamilton wanted to do, actually? And this is, I believe, misunderstood by this famous paper here. Hamilton's big ambition when he was a student, already when he was an undergraduate at Cambridge, was to make some kind of big contribution to the theory of evolution. And his hero was R.A. Fisher. You know, Fisher has also come up with the analysis of variance. He was a great statistician, but he was also a good Darwinist. He owned all 13 volumes of Darwin, and he took it with him when he was a student. So he was also a naturalist of sort, but he was okay. So his Fisher's famous Fisher had a famous theorem, and a famous book. The book was called The Genetical Theory of Natural Selection, and the famous theorem was called the fundamental theorem of natural selection. Okay, so what was the fundamental theorem of natural selection according to Fisher? It was like, how do we express evolution at all in a quantitative way? Well, what are individuals doing? Like, and he said, individuals are acting as if they are trying to maximize their own fitness. And fitness meaning reproductive success. And this is like the driving force of evolution. But Hamilton started thinking more about this. He was totally fascinated with Fisher. Nobody liked Fisher. His advisors at Cambridge told him, don't read Fisher, he doesn't know anything. And Hamilton said, I'm going to read Fisher, and he read. And then he said to himself, well, there is maybe more to this than individuals striving to maximize their own fitness as a kind of model, which you can actually express mathematically in neo-Darwinian population genetical terms. Like you can see evolution as a change of gene frequencies in a population. He was thinking, well, individuals very often are grouped together with other individuals. They live they have social life. So obviously they affect each other if they live together in some way. And that has to be expressed somehow. And that is why he decided to improve on Fisher's fundamental theorem and make it a little more fundamental. So that is why he said to him, fitness is not enough. It's not only the individual's fitness, because if you look at it, the whole situation from the gene's point of view, it is the genes that needs to be propagated, which is the idea of evolution, also exist in other individuals, particularly relatives. So that's why he called his theory inclusive fitness. Okay, that was his contribution. Now, why do we call it? Why do we talk about kin selection? Well, we have the ever fast-working and elegant formulation of elegantly formulating person, Maynard Smith, who, when he realized what this was about, I'm not sure he quite got the inclusive fitness right either, but he said, "Oh, I see. So it mostly is going to be kin because these are the ones that live socially together with each other. Why don't we call it kin selection?" And Maynard Smith at the time had been looking for, together with David Leck and I think Arthur Kane, they had been looking for, like, isn't there some answer to this terrible theory by Verovin Edwards, who was a naturalist who had come up with an attempt to explain how group selection worked. It had to do with self-sacrifice of groups of birds who were kind of signaling to each other in big displays and assessing like what the population was, and maybe they should now refrain from reproducing more because they don't have enough resources if they want to stay in the same area, something along these lines. I think that this was not what these leading biologists wanted at all. They were looking for something else. And here comes Hamilton's theory, which Maynard Smith then called kin selection. And from that time on, it was a very elegant term. It was very intuitively clear. But from that time on, people looked at kin selection and inclusive fitness interchangeably, okay, and thought it was the same thing. Okay. And the interesting thing is that Hamilton did not speak up loudly enough, and this is a puzzle. Okay. By the way, for Hamilton, so what was the difference? For Hamilton, it was not only relatives at all, it was anybody who would carry that particular allele for altruism. Again, it sounds kind of funny, but that is the way it was formulated. In his 64 paper, he even said that, he said, what about foolishly helpful friends? Foolishly helpful friends are friends that are so close to you that they are like brothers with you, and they help you, and they just don't think about time and effort spent. They just show up. We all have such friends, or we maybe are such friends to others. So he was thinking, what mechanism is working here? These are not relatives. So what he was saying already in his 64 paper was that there must exist some type of phenotypical recognition mechanism that makes it possible for individuals who share altruistic traits to identify one another. And he called that super kinship trait. It was not kinship, but it was super. And Richard Dawkins later called this the Greenbeard effect. Okay, so there was already a core of a core of misunderstanding about what kin selection was and what inclusive fitness was. Then comes another thing that was misunderstood. Hamilton, I have read many of his letters. He had an impossible handwriting. It took forever to read those letters. In his letters to his close friend Colin Hudson, he says, at a particular date, he says, I think I have found a marvelous example of this idea that I am researching, and that is Hymenoptera. It seems that they follow exactly this, my calculation, and they do this, they do that. I mean, they are haplodiploid, and this way, one should expect particular results, and he got them when he calculated. He may have made a mistake, but anyway, he was very convinced there. And he published this as one of the good examples of how his theory works. And I think he was very proud of it because his advisors have been really very skeptical about his formulas and said, you have to have real evidence. Thank you. Yes, so he was very proud when he had found this. And he was very happy because his advisors had been very skeptical and they wanted to have some good evidence. So here he had it. And what I believe happened here was that E.O. Wilson, at the time, when he read Hamilton's paper, he read it already in 65, I think, very early on. He was writing a book on the social insects at the time. And he describes in his autobiography how he was sitting on a train and reading this paper and said to himself, this cannot be true, no, this is ridiculous, so on. He was struggling with himself, and then he finally said, okay, maybe there is something to it. So that is a rather moving little paragraph that he has there. So for a time, I think Wilson was totally enthralled with kin selection theory as a possibility. And I remember he even backed up Hamilton at the entomological conference in London, where Hamilton was presenting a paper. So there was some kind of support for the idea. But I think at the same time, what was being ingrained in Ed Wilson's mind was that kin selection had something to do with Hymenoptera, and that I think that he got stuck with that. And I think that has affected his further thinking about the thing. Because in this paper here, there's some kind of gliding approach or some kind of unclarity. What are they actually talking about? They talk about the evolution of eusociality, which is, of course, very extremely important issue and a wonderful topic. And here, of course, Wilson, together with Hildebler, who is here, by the way, had written this wonderful big book about the superorganism, where they actually had cracked like how it actually works, and they were like totally inside the whole machinery there and everything. So if anybody knew about how it works, it's Wilson. But what this article is about is a kind of mathematical model which is supposed to prove the model is not in the main text, it is in supplementary. I believe it's part of the supplementary online part, which not everybody read, I guess. But this article contains arguments about kin selection, which in general, which are not related to the evolution of eusociality. So it seems to me and to many other people too, that Wilson believed that if you can show that some claims about eusociality that Hamilton also made or some suggestions in his 64 paper, if those are wrong, everything falls to pieces. So Wilson has been supporting of kin selection, but I think mostly in regard to eusociality. Okay. Now comes another interesting issue that is at the I think core of, at the center of this new controversy about kin selection. You know, how good is it, and what is it really, and so on. And that is the so-called Price equation. Okay. Price was a colleague that was trying to rederive Hamilton's formula from scratch. He was brilliant. He was a computer programmer and also a scientist. And he just from scratch rederive. He did not like the idea of kin selection. I think many people don't like this idea because it sounds like kin. We should all hold hands and be only together with kin. No, there is a world out there. So Price was one of these kind of positive thinkers, and he said, like, I'm going to crack this Hamilton's formula and show that he's wrong. And he tried hard, but actually he couldn't. Meanwhile, he was inventing by default, because he was bright with mathematics, he came up with something called the Price equation. And the Price equation was a way in which you could statistically apportion in-group variation and variation between groups, which was, of course, a very big, which was a big issue. If you want to have something called group selection, which some people still wanted to have, you have to prove that it is between groups, and that is possible, and that the groups actually can exist and will not get overwhelmed by selfish genes that invade them and just out-reproduce altruistic genes, or out kind of compete them. So Price made a contribution which was extremely good, and with his help, it was now possible to actually use either kind of kin selection formulas or this kind of group selection thinking, because under certain conditions it was indeed possible for, or it hypothetically would be possible for groups to actually compete instead of being outsmarted by these selfish invaders or something, which was why Maynard Smith originally said that group selection is possible but not very probable, because he cannot see how it can really happen in nature. And George Williams said the same, and that is why ever since the 70s or so, for Williams, of course, from the 60s, he wrote this book, 66, his famous book, Adaptation and Natural Selection. So I think that for 50 years, it has been a kind of paradigm which has been very much discouraging research in group selection, not forbidding it, but discouraging it. And this is what I think Wilson and his colleagues want to pull back. The funny thing is, though, that this whole idea of a multi-level approach and about the actual equality, mathematic equality between group selection and kin selection was all in a paper by Hamilton in 1975, which was called Innate Social Aptitudes of Man, which was published as a chapter in a biosocial anthropology conference book. And in that paper is important because this is the first time where Hamilton speaks up. And he says kin selection is not the same as inclusive fitness. Inclusive fitness is far broader, and we don't have to involve actual kinship between donor and recipient. It has to do with carriers of altruistic genes recognizing one another. It has to do with assortation. So he says, or another way of putting it is kinship should be considered just one way of getting positive regression of genotype in the recipient. And it is this positive regression that is vitally necessary for altruism. thus the inclusive fitness concept is more general than kin selection. And then he says that there are lots of possibilities. He says, if we insist that group selection is different than kin selection, which is what Maynard Smith was doing, then the term should be restricted to situations of assertion which doesn't involve kin. But I think it is on the whole more preferable to retain a flexible use of terms. So we use group selection where groups are clearly in evidence, and we qualify with mention of kin, relatedness, or low migration, which is often the cause of relatedness in group, or otherwise we call it assertion or whatever. So he had the mathematics that was involved here discussed multi-level selection and discussed and the tension between various levels, and it discussed the equivalence of these two. So how come that not more people knew about this? How do I know that not more people knew about this? I mean, because D.S. Wilson, who does interesting things occasionally, was doing an inventory of how many people were referring over a period of years, maybe a decade or so, how many people were referring to Hamilton's 64 paper versus his 75 paper, and it was a proportion 15:1. So it was relatively invisible. And of course one can say that it is rather obvious that people don't go and look for a biosocial anthropology book in order to look for something that has to do with inclusive fitness, but that was actually one of the few times that Hamilton was actually talking about humans. He was invited by Robin Fox and he accepted. It was at Oxford. But I think that there is something more to it. It's not only so that he published it in this book. Why did he never really write a special note? I mean, he didn't do that in general, so it was not his style. But he could really have written something saying, hey guys, kin selection is not the same as inclusive fitness. I think that people are getting this wrong. And he didn't do that. Why? Now, psychologically, I have thought the following, that there was something resisting him to do that inside himself, because he had been struggling so hard with deriving this inclusive fitness formula. He was sitting, he has described it in letters and also in his autobiographical notes, he was sitting day after day and his papers were flying around and he was just scratching his head and he couldn't get anywhere. He just made so many mistakes and stuff. So all this effort, it would be so sad not to recognize this as actually his grand effort or his grand achievement, because I didn't say this, but now comes the point. Because why is it equivalent? Why are these group selection and kin selection kind of equivalent mathematically? Because Hamilton actually picked up Price's wonderful mathematics tool and used it to rederive his inclusive fitness formula, this time from group selectionist premises, and it worked. And that is why, ever since, group selection and kin selection, when it comes to this Price's formula, can work in the same way. But I think Hamilton did not want to be seen as a group selectionist, although he was very competent. He actually, when he was at University of Michigan, where he went in 1977, he was teaching group selection, he was teaching Price's formula and teaching his students, David Queller and everybody who is somebody was, it seems, was Hamilton's student. He taught them group selection, Steve Frank, and he did it so well that his students thought he was a group selectionist, okay? Meaning that he actually could operate from both kin selection and group selection. But this is not well known. But his student learned a lot. I mean, Steve Frank is very often dealing with group selectionist kind of approaches, and he is a specialist on the price formula particularly. And Dave Weller is all over the place. He just cannot operate in almost in any mode. So I think that Hamilton did not want, and Hamilton did not want to speak up about this too much. And also he hated group selection. Why? Because for him, group selection was, and this is not my interpretation, he says it somewhere, you just have to dig it out from these massive books. He associated group selection with Nazism and totalitarianism and so on. Other people, his hypothetical readers of this article, which was about social aptitudes of man after all, it was an anthropological article. His readers, those who read it and found it, Trivers somewhere noted that they called him, he referred to it as Hamilton's fascist paper. So it was like Nazi, it was, I have seen racist also. It was a terrible paper because it talks about, it was not a terrible paper at all. He just used humans as his organism there. But he showed that what is good at one level of selection is not good at another level of selection. That's where we have tension. And so he actually introduces this in-group, out-group tension also. Okay, so hurry up here a little. So what was this paper? What are they saying in this paper? Just a quick, let's see. Yes. So according to Wilson and his two colleagues, kin selection, which they identified with inclusive fitness, and actually, in general, it has been used interchangeably. So this does not indicate that they made a mistake, but it may be that they actually thought about it in the wrong way. And so they say that kin selection should just be substituted with regular natural selection instead. This was very surprising to some people. They argue that inclusive fitness was very difficult to calculate. They saw inclusive fitness as an accountancy system. And also that this system had not generated any empirical results. And the theory of kin selection was not holding up in the light of empirical evidence. And this was, so they said that time has come to substitute kin selection with group selection, or rather multi-level selection. And they wanted then to show that this is possible, that we don't need kin selection, because under particular ecological condition, such as having a food source or needing or a nest and a need to have common defense, the cooperation of totally unrelated insects can give rise to eusociality. So the basic point that they wanted to convey was that genetic relatedness was not needed. Okay, and many people may not have looked at the supplementary material here, so where they explain things in more detail. But what struck many people immediately was when they saw kin selection, when they read things like kin selection is wrong or kin selection hasn't produced any results. They said, like, what? We have been doing this like 30 years. We have lots of students. We have developed theory. We have incredible empirical studies. We have taken this theory much further. There are new like mathematical derivations and stuff. Like, what? So they didn't understand what was happening. And what the result of the reaction of regular scientists was not like, this is madness, but they said like, something is wrong here. And they got together in various clusters, depending on who knew whom and what they represented. We had mathematically organized people like Michaud, for instance. I think he's very mathematical population geneticist. I saw his name somewhere. And we have other people. Some people were into eusociality. Some people were into applications of kin selection. And there were like 5 different clusters of people, and together 150 or so letters that came as an answer, dear editor, we disagree. And these letters were very well formulated. They were like small papers, calmly and kind of in a calm formulation with lots of references. So it was a fantastic, actually, for students today. It's a fantastic source of information about who is who, in what kind of cluster they are, what they think, and all these references. And I think it actually was maybe good for the field in the sense that people now got to know each other a little more and maybe got to know about other people whom they hadn't known before. In other words, it probably caused some kind of integration of the field of sociobiology at large, even better than before, which is something that actually E.O. Wilson would have liked, or should have liked, because his sociobiology originally was also an attempt to integrate lots of scattered fields. Okay, now I get to another point here, which is this is really hard to understand. This is not the only paper in which Wilson was opposed to kin selection in the 2000s. Actually, when I visited him in 2005 to ask him something about Hamilton, in the end he gave me in my hand and said, his sociology paper written together with Holberger, and said, here is something, things are changing totally, we have a new paradigm. And I was like, whoops, but that was at the very end of our interview. So already 2005, he was planning, he was writing his superorganism book. And he started writing papers which were very critical of kin selection. So this was not the first, but this was the first mathematical model, because I believe that Wilson needs a mathematical model to feel that he has to convince the community. So I have been wondering, in addition to deep scientific commitments, which of course exist, and I think that Wilson has a very deep commitment to group selection, and he never really liked kin selection anyway. But I think there may be also some kind of moral component here. Moral, I would say more moral than political. Wilson is not so political. He's more like deeply morally concerned. And I think that the concern here could be the following. And if you read On Human Nature, and go back and read that book, you can see that similar concerns exist there. People don't change so much, I think, to their moral visions. I think he doesn't like the word kin selection because it has the word kin, and it kind of may make people think that kin is what we need to stick with. That is not a very good formula for the world, and he wants to have a universal theory. Another thing he certainly doesn't like is a selfish gene. I mean, lots of people didn't like the selfish gene. I talked to Karl Popper, the philosopher, and I wanted to ask him, is evolution, is evolutionary theory scientific theory? Because he had just been talking about what is a scientific theory. And he didn't answer, really, but instead he said, I said, so think about, Dawkins' book, The Selfish Gene, and how he explains all this in a kind of very clear way. And he said, that's ideology. It's like, oops, okay, that was Karl Popper. His first reaction was not philosophical, scientific, but it was rather ideological, or like the meaning of it. And now I go back quickly to my own sociobiology, my own defenders of the truth, because what I realized that the sociobiology controversy had to do with was partially deep different convictions about evolutionary theory. And that is really true. And one cannot just say that everybody's a Marxist if one wants to get rid of them, for instance. That was something that was being said at the time. So they are Marxist. Well, they may be Marxist, but they have a deep feeling for like a more group and holistic orientation to the world, which actually Wilson himself has. But the opponents didn't like adaptation, because why? Adaptation sounds innocent, perhaps, but you can look at the possible implications, and if you really are good at looking at implications, you can find terrible implications. What does it mean, adaptation? People are less or more adapted. That sounds kind of insulting to people. So therefore, you had Gould, who was trying to explain that adaptation is not really the driving force, and you have all kinds of randomness and things, and all kinds of anti-adaptationist theory. And then you have Lewontin saying somewhere, a biblical quote saying, everybody gets their chance, you know. The race is not to the brave, or is it swift? I don't know this quote very well, but chance happeneth to them all. So you want to have. So my conclusion was that there was a quest for a kind of, many people had a quest for a theory that if it was implemented and taken at a social level and taken as a kind of social message, then it should be something which doesn't lead to terrible things. Okay. So therefore I can understand Wilson's wish to push for group selection and irritation with kin selection as a term, because it sounds rather bad. If people take it as a command from nature, that this is natural, so now we should be doing the same. Who knows? So I can follow Wilson this far if that is a kind of thing driving him. But there is also another question. Then what about his statement in The Social Conquest of Earth, which is one of his newer books, 2012, where he says, yes, cooperation is very important, and humans are cooperative. He was comparing insects and humans from the point of view that cooperation is a very important driving force, which I think was a good idea and probably is true. But then he was saying, but the other side of cooperation for humans is group conflict. Okay, so you can't get away from that. You will have to have, in order to have good in-group cooperation, you will have to have between-group conflict. That, and you know, this conjures up a vision of slaughter over millennia and so on, and you know, just groups eliminating each other, because the group selection that Wilson had in mind is a kind of groups that eliminate other groups. It is not any didless thing. It's really whole groups that do things. And this is not, I think, a good message either, because that kind of legitimizes, from the point of view of all the critics of sociobiology, that would legitimize, so to say, elimination of groups, which is like war. That's terrible. So that's why I am very happy, but because I have this same, I can feel the same feelings, so I can kind of think the same thoughts. Therefore, I think it's wonderful to explore other opportunities and other possibilities of theories, which doesn't make cooperation now having this dark side. And I think here at ASU we have wonderful people who are looking at cultural group selection and other kinds of ways in which cooperation can have happen without this slaughter that some people kind of now deem necessary, because we don't want to have that as a model either. Okay, I think I will stop here, because otherwise you will not have any questions. Okay. Hold up, hold up, here.
With our microphone problems, I think we're going to.
I would like,
Oh, okay, yes.
I would like to, instead of a question, make a few comments.
Yes.
Because, I start at the very beginning, at the very end. You clearly have misunderstood Wilson when you think he is propagating warfare in humans, but there is clearly, wherever we find social life on this earth, and whether these are bacteria, social insects, and you have highly cooperative groups, and now forget for a moment the humans, you have the discrimination and rejections of members of other groups of the same species. You find no exception of that. And this is, you know, it's well known that in evolution, competition among other groups drives the evolution within group evolution of cooperation. And I think
So
it certainly did not justify in this book.
Yeah. I didn't mean that he would have
but
justified
it sounded a little bit, so
Oh,
I
no,
had to,
no,
to,
no,
to,
no.
just correct it. But
No, I just
wanted
meant
to
that it
say
could be so.
From the end, Popper never understood evolution. He never really understood what it is, evolution. I have studied Popper and his sort of the circular reasoning, and I said this man has not read a basic good introductory book to evolution. He never understood evolution.
That's possible.
So he's a brilliant man,
Yeah.
but he did not understand
Yes.
evolution.
Yes.
Probably he had a totally childish misconception of what evolution is. This is just to, now I wanted to say, you mentioned the paper I wrote with Ed, which is, from my point of view, the worst paper I ever published.
Yeah, I didn't mention that.
Because we already had at that time diverging views, and we thought, or Ed convinced me, and it was my mistake that I gave in, that we can publish a perspective paper in PNAS of short of saying, and this was all where we agreed, a pure gene selectionist perspective, like selfish gene,
Yeah.
which I don't say it's wrong, but it gives us a myopic view where selection operates on and forgets the phenotype. So we wanted to come back to Darwin and say it is the phenotype which selection evaluates.
Exactly, yeah.
And then under certain circumstances, and I'm very restrictive, the social insects are one of the few examples where it can be the group, but not the group as it is usually discussed in group selection. There's only one of the few reproductives. And the many other individuals are basically functioning as the extended phenotype of these reproductives.
Yeah, that's a wonderful parallel.
So,
Yeah.
and if you look at this paper, there is one book not cited, and this is the superorganism, which Ed Wilson, of course, is the co-author, but he didn't cite it. I said, I told Ed,
Yeah.
I know very well why you didn't cite it,
Yeah.
because chapter 2 not only criticizes the paper we have written together severely, it also criticizes his view. The only mistake, chapter 2 was assigned to Ed, and I did not publish the book for 2 years, did not agree, because I said, I don't publish this again. I did it once in PNS, and then we agreed that I take over and write chapter 2.
Yeah, I thought you had written it.
And it was generally very well reviewed, but interestingly, it's not cited in the Novak paper.
I didn't see
It's
that. Thank you.
only in the appendix, in the long appendix.
Yeah,
No one looks at the appendix. And the last thing I wanted to say, I'm not sure if you are right with your statement saying in the 50s and 60s everyone was thinking about group selection. It was true. Most behavioral biologists, and especially the European and the Lorentzian school, they were thinking in group selectionist terms, and this is good for the species thinking. But you know, George Williams already long before, they didn't read the behavioral literature, but George Williams then in Chicago heard once Emerson talking, and he said, he was literally shocked. He said, God, they have a totally distorted view of evolutionary biology. But you know, Haldane and all this, but look at Ernst Mayer's book, you don't find really group selectionists. Ernst Mayr mentioned it, but critically.
Yeah.
Ernst was always a Darwinian selectionist. And Ernst said, of Lawrence, he said, you know, Conrad is very clever, but he has never read Darwin. Otherwise, he would not say that. Group selection thinking. So I think it was, and this was a great synthesis in my view, that finally population genetics and behavioral biology came together. And Ed had a major influence on that in his early time.
Yes.
But the last question we talked yesterday at length why did Ed change his mind and came to that? I have not figured it out entirely.
No, this is my talent.
So I just wanted to...
Thank you very, very much. Yes, I am sorry if I misled anybody. No. Yes, I did not want to say...
close on time, but today we're not going to.
Just
We're
want
going
to
to give
say-
Ullica a chance to offer further comments.
Thank you very much. This was wonderful, and it's good to have it on record. Yes, I did not want to say anything bad about EO at all. I mean, I know that he has great ambitions with this book, The Social Conquest of Earth, and so on. I just mean that it was a little disappointing that he ended up with this statement, which he also wrote in a popular article in New York Times, that we have this inevitable tension. I mean, he's brave enough to talk about inevitable tensions and between in-group and out-group. It's like the price to pay or something. Which is, of course, we are all adults and we should be able to handle it and so on. And I don't say he's recommending it, but if I put on my hat of the critics, which I did when I was writing Defenders of the Truth, what kind of message does it say? And maybe, and I think also that he cites evidence which talks about these group extinctions and so on actually as war. And it may be true, but other people are looking for other explanations, for instance, migration and adoption of a new culture and integration into a new culture, which is not the same as extinction in a physical way. And I mean, it's good to look at different kinds of possibilities. But certainly, time has come certainly to get rid of the selfish gene and kin selection as kind of terms, because people out there don't really know what they mean, and they may take them as kind of models to feature, which is not good. This is happening very much, I think, in this country particularly. If you think about the misunderstanding of the selfish gene, it was a bad choice in the first place to have such a title. So on. It was just amazing how the laymen, people in general, took things. The Swedes were extremely angry with the selfish gene and Dawkins, and the idea of the selfish gene. And meanwhile, they loved Hamilton. I realized this when I read some Swedish newspapers. Why? I mean, Hamilton and Dawkins were actually saying the same thing, but they didn't understand that. So people take words very seriously, and that's dangerous, perhaps.
So there's a class in here. Want to make any last comments before we wrap up?
No, thank you. You have been a good audience.